Hello dear students, welcome to Physics class 3. In this class, let us derive an expression for torque on a dipole in a uniform electric field. Before going to this derivation, let me explain the definition of three terms. One is torque, second one is dipole, third one is uniform electric field. Torque nothing but turning effect of force about a fixed axis. And dipole means two equal and opposite charges separated by a very small distance. And uniform electric field means it is a space in which the strength or the intensity of electric field will be same. And now consider the uniform electric field. Uniform electric field is represented by a straight line. The straight line represents uniform electric field, that is A vector. In this uniform electric field, let us consider dipole. Let us place a dipole. Dipole means one is a positive charge plus Q, second one is a negative charge minus Q, separated by a small distance to A. Now join these two charges by a line is called dipole axis. This is a dipole axis, and dipole has dipole moment, and that dipole moment always directed from negative charge to positive charge. This is a dipole moment. It is represented by P vector. So whenever we place any charge in uniform or in non-uniform electric field, some force will experienced by that charge, and that force is given by E into Q. This is the product of electric field into charge, nothing but force acting on positive charge, because the definition of electric field is it is a ratio of force to the charge. Force acting per unit charge is called electric field. To find force, cross multiplication, EQ is equals to F. The force acting on any charge in uniform electric field is given by A into Q. Therefore, this is E into Q. And the force acting similarly on negative charge is, again it is A into Q. But here observe, this is positive charge, this is negative charge. Whenever charge is positive, then the direction of force always in the direction of electric field. So this is positive charge, therefore force direction is always in the direction of electric field. But if you consider negative charge, then it becomes minus EQ is equals to F, that represent force and electric field are in opposite direction. That's why here I shown the force acting on negative charge is opposite to the direction of electric field. Okay. So now the torque is defined as, whenever we place a dipole in uniform electric field, torque will act on the dipole, and that torque is defined as, torque symbol is tau. It is a magnitude of either force. It is a magnitude of either force into magnitude of either force into perpendicular distance between two forces. Perpendicular distance between two forces. This is the definition of torque. So here we have two forces acting on two charges. You have to consider any one force, but magnitude of either force. Don't take negative sign, because if you take this one, you will get minus. So magnitude of either force means it is EQ, because force nothing but product of electric field and charge, into perpendicular distance between two forces. This is one force, this is one more force. Here we don't have perpendicular distance. To get the perpendicular distance, or draw a dotted line from here to here, and this is the perpendicular distance. Give some names. Let us consider this is A, this is B, let us consider this as C. Now what is the perpendicular distance here? That is BC. This is the perpendicular distance between two forces. Now that is equals to EQ into BC value. So how to find BC? If you observe this figure, the dipole axis makes some angle theta with the direction of the electric field. So this is the angle. This is a dipole axis makes an angle theta with the electric field. So these two are similar angles. These two are similar angles. So this is theta means adjacent, opposite, hypotenuse. If here you want to find BC value, that is opposite side, therefore take sin theta. Therefore from figure, sin theta is nothing but opposite by hypotenuse. And what is the opposite here? BC is the opposite and hypotenuse is 2a. This is the hypotenuse and its value is already written 2a. So cross multiplication, 2a sin theta is equals to BC. This is the value of, that is a BC, opposite side. Therefore torque tau is equals to EQ into BC, nothing but it is 2a sin theta. Clear? And now make use of the definition of dipole moment. And dipole moment definition is P is equals to product of either charge, magnitude of either charge into small distance to A. So from this definition we can replace Q into 2A as P. Therefore it is PE sin theta. This is the torque acting on dipole by dipole placed in uniform electric field. This is in scalar form. Also we can write the torque in vector form, and it is given by tau is equals to, in vector form, tau vector is equals to P vector cross E vector. This is in vector form. And tau is equals to P sin theta. This is in scalar form, where theta is the angle between dipole moment and the electric field. Theta is the angle between dipole moment and electric field. Now let us discuss some cases, that is the maximum torque and minimum torque. So first one, let us consider minimum torque. Minimum torque, when torque is said to be minimum, when dipole is said to be stable equilibrium. So stable equilibrium means dipole doesn't rotate, doesn't affected by the uniform electric field. That condition is theta is equals to 0 degree. So that means if P is parallel to dipole moment, he is parallel to dipole or lie along the electric field or parallel to electric field, then the angle between them is 0. Then what happens? Torque nothing but P is sin theta, theta is 0, sin 0 is 0, 0 into anything is 0. This is the minimum. We can say torque is a minimum at theta is equals to 0 degree, or dipole moment is along or parallel to the electric field. Similarly, maximum torque, when torque on dipole is maximum means you have to place dipole moment at right angle to the electric field, that is theta is equals to 90 degree. Dipole moment is perpendicular to electric field. Then what happens? Torque becomes P is sin theta, theta is 90 and sin 90 degree value is 1 into P is P. This is the torque, and we can say this as a maximum torque.